In this lecture, we have discussed the solutions of second order linear differential equation, homogeneous differential equations. We'll just recall that statement and solve the example. Let me admit all the people.
Raj,
Recall that your linear differential equations of second order will be given by this homogeneous differential equation. Then characteristic equation given by r square a1r plus a2 equal to 0. या ठिकाणी फक्त रिप्लेस करायचं आपल्याला तर y nth डेरिव्हेटिव्ह असेल तर r टू द n ने रिप्लेस करायचं आणि y काय नाही म्हणजे झिरो डेरिव्हेटिव्ह म्हणजे काय असेल r टू द पॉवर 0 1 लिहायचं हे लक्षात ठेवा. बऱ्याच वेळा आपण इथे r लिहितो. ही गोष्ट लक्षात घ्या. याचे रूट्स असतील क्वाड्रेटिक इक्वेशन फंडामेंटल थेरम ऑफ अल्जेब्रा प्रमाणे याला रूट्स असतील त्याचे रूट्स आपण r1 r2 असं डिनोट करू. याच्यामध्ये दोन केसेस आहेत. r1 r2 जर वेगवेगळे असतील तर हे e टू द पॉवर r1 x टू द पॉवर r2 x हे दोन इंडिपेंडेंट फंक्शन असतील जे दोघेही सोल्युशन असतील. ऑल सोल्युशन्स फाइंड करायचं असेल तर c1 टू द पॉवर r1 x प्लस c2 हे सुद्धा ते सॅटिस्फाय करत. c1 c2 विल बी एनी कॉन्स्टंट्स. ऑल सोल्युशन फाइंड करायचं असेल तर हे असेल. आणि आणखी याच्यामध्ये टू इंडिपेंडेंट आता ऑर्डर 2 असल्यामुळे टू इंडिपेंडेंट सोल्युशन येतील या ठिकाणी. सेकंड केसमध्ये जर रिपीटेड रूट्स असतील या ठिकाणी e टू द पॉवर r1 x आणि e टू द पॉवर r2 x असं लिहून जमणार नाही कारण r1 x r2 x एकच आहे. आता इंडिपेंडेंट सोल्युशन्स करायचे असतील तर आपण याला x मल्टिप्लाय केलं या ठिकाणी. का केलं ते आपण कालच्या रिझल्टमध्ये पाहिलेलं आहे. आणि याचा ऑल सोल्युशन्स फाइंड करायचं असेल तर जस्ट मल्टिप्लाय बाय द कॉन्स्टंट देअर लिनियर कॉम्बिनेशन. ऑल सोल्युशन मीन्स यू आर रायटिंग लिनियर कॉम्बिनेशन ऑफ दिस टू इंडिपेंडेंट सोल्युशन. हा सोल्युशन स्पेस तयार होईल या ठिकाणी त्याचा दिलेला डिफरन्शियल इक्वेशन. तो की वेक्टर स्पेस असतो आणि हे जर त्याचे दोन बेसिस आहे असं म्हटलं आपण तर त्याचे डायमेन्शन काय या ठिकाणी डायमेन्शन म्हणजे ते ऑर्डर समजा डिफरन्शियल इक्वेशनची या ठिकाणी. कॉम्प्लेक्स वगैरे रूट्स आहे असं आपण काही केस केलेलं नाही त्या ठिकाणी. ते आपण एक्झाम्पल मध्ये पाहू. फक्त एक गोष्ट लक्षात घेतली आपण की या ठिकाणी युलर्स फॉर्म्युला आपण वापरणार आहोत. e टू द पॉवर i थीटा इट इज cos theta plus I sin theta. And if it is negative power e to the power, okay, when you write complex number we will never say negative or positive. E to the power minus I theta cos theta minus I sin theta. Now we try to solve following examples. Find all solution means you have to find general solution. Find all solutions of the following one by one. So first differential equation is this. This is equal to 0. So given differential equation is y double dash plus y dash minus 2y is equal to 0, and its characteristic equation is r square minus r plus 2 is equal to 0. And we can factorize it easily to find the roots of this equation. So your first aim is to find the roots of this characteristic equation always. And depending on the nature of that root, we can write the solution. So what are the roots of these two equations? We can factorize it. This step we have to find solution of this. So
2 and minus.
Okay, 2 and that means you can write r minus 2 and r plus 1 like this factor. So r is 2 and r is -1. So -1 and 2 will write always increasing order. -1 and 2 are the roots of this equation. We have written the equation wrongly here. Here should be plus. If it is plus, then here should be plus and here should be minus. Then it becomes 2 and this becomes +1 like this. So be careful about writing equation. So r square plus r minus 2 has this factorization. So your case is that this -2 and 1 are different. So you have solutions. What are the solutions? Your phi 1 is e to the power -2x and phi 2 is e to the power x. These two are the solutions. These two are independent solutions. And general solution or all solutions, every solution, all solutions is every solution writing. Every solution of given what is equation, given differential equation y dash plus y double dash plus y dash minus 2y is equal to 0 is phi is equal to the constant times phi 1, that is e to the power -2x plus another constant times e to the power x. So this is every solution. प्रत्येक सोल्युशन ह्या पॅटर्न मध्ये असेल. कोणतंही सोल्युशन असेल तर या दोघांचे लिनियर कॉम्बिनेशन ते लिहिता येईल. जसं फर्स्ट ऑर्डरचं असेल तर ते फर्स्ट ऑर्डरचं असेल तर आपल्याला एकच इंडिपेंडंट सोल्युशन मिळतं. दुसरं कोणतंही सोल्युशन असेल तर आपण तिथे काय म्हणतो, दुसरं कोणतंही सोल्युशन असेल तर त्या ठिकाणी ते त्याच्या लिनियर कॉम्बिनेशन मध्ये असते. Everybody mark your attendance. So this is the solutions. Every solution of this differential equation is of this form. So you can see this is also solution. You have found this is solution. So here constant is 1 and another constant is 0. This is also solution. Here first constant is 0, another constant is 1 like that. So these two are the independent solution of given differential equation. If order is n, you must have n linearly independent solutions, and every linear combination of this linearly independent solution is a solution of that. Every solution is of that form, the linear combination of all these. So I write second example now. Where omega is constant. Okay, we can say positive constant. The characteristic equation of this, I'll use shortcut method now. The characteristic equation of this is r square plus omega square is 0. So that means r square is minus omega square. So this implies r is square root of -1 minus omega square. I'll write first. Omega square means omega and it is square root of -1. So it is omega I. Taking square root, degree is 2. So you must have 2 roots of that. So R1 is omega I and R2 is minus omega I. So two solutions of this, basic two solutions of this differential equation is our first solution phi 1 e to the power omega I into x, and second solution e to the power R2x. R2 means minus omega ix. And every solution of this differential equation given as constant times this phi 1 e to the power I omega x plus another constant times e to the power minus I omega x. So this is every solution. प्रत्येक सोल्युशन डिफरन्शियल इक्वेशन असं देत आहे. त्याला आपण फर्दर फॉर्म मध्ये पण रिड्यूस करू शकतो. जसं की आपण पाहिले e to the power I theta युलर्स फॉर्म्युला cos theta plus I sin theta असेल तर याला आपण असे लिहू शकतो C1 cos of omega x plus I sin omega x plus C2 cos of omega x minus I sin omega x to the power I theta e to the power minus I theta we are writing. So C1 plus C2 is cos omega x plus I C1 minus I C2 is sin omega x. So these are another new complex constants. You can say d1 cos omega x plus d2 sin omega x. Once you have degree 2 order 2 must have two constant in the solution. So this every solution may be given in this form. We are divided into other complex constants. Sometimes they may be real. Okay, this was simple example. Now we'll have another. Okay, you unmute yourself and tell me the solution of every differential equation. Such type of questions may ask in the MCQ. What is the solution of it? Just write down on your notebook if you have it now right now. Okay, solve one by one all. Take a screenshot of this. You can have a screenshot of it. One students forgot to mark attendance. Those who have forgot, mark your attendance. Okay. For the C part, it is r square minus 4 equal to 0. So r is 2. Since degree is 2, you must have two roots. So r minus 2 square. Not r minus 2 square it is. R is 4. So it is plus or minus 2 actually. These are distinct roots. R is 2 and r is minus 2. E to the power 2x and e to the power minus 2x. These two are the solutions. And every solution of the first equation is given by c1 e to the power minus 2x plus c2 e to the power plus 2x. Every solution is given by this. Likewise, we have to write all. What is the C D part? For the D, you have equations 3r square plus 2r equal to 0 because y dash is r. So you can find easily root of this equation. R into 3r plus 2 equal to 0. What are the roots of these equations? R is 0 and r is minus 2 upon 3. I'm skipping all the steps. I'm giving hints. I'm not solving this completely. You have to write in right manner. That given differential equation is this, then its characteristic equation is given by these roots of this characteristic equation, so and so. And once you find the roots, you have two solutions of this equation. Phi 1 is e to the power 0x, phi 2 is e to the power minus 2 by 3x. And every solution of this differential equation is given like this: c1 phi 1 plus c2 phi 2. So what is phi 1? Phi 1 is just e to the power 0x means it is 1. C1 plus C2 into uh, e to the power minus 2 by 3x. So this is the general solution. आलेलं येते लक्षात कसं लिहायचं. I'm not going to write all the steps. Next, E part. What is E part? Okay, you tell me about this. You can write for this. What is characteristic equation for this? Characteristic equation for this, Akash power. Akash. Akash power. Hola, Akash. I will remove you from the class. Student answer. Okay. Next one, Akash Aradwad. Aradwade Akash.
4, sir.
It's a character equation. This I have written on the screen.
Plus minus 4.
Okay, you are telling roots directly. Plus or minus 4 I. Minus 16 वरनं पलीकडे गेल्यावर. This is r square is minus 16. Root of 16 is 4 plus or minus 4. But what is root of minus 1? It is I. So these two are the complex roots. So first solution is e to the power 4ix, and another solution is e to the power minus 4ix. And every solution is given by this. You can use the Euler's formula, that C1 into cos 4x plus I sin 4x. Expansion of this e to the power 4ix, and C2 into cos 4x minus I sin 4x. And another constant you can give it as C1 plus C2 multiplied by cos of 4x plus IC1 minus IC2 multiplied by sin 4x. One can directly write this as the constant times cos. Use any notation for the constants. So when you have purely imaginary number as a root like this, 4x into I. So you just write constant times cos of, suppose you have root like this AI is a root plus or minus AI. Then solution you can put d1 cos ax plus d2 sin ax. Directly you can write, or you can use this procedure also. But don't write C1 plus C2, you just add new constant for C1, C1 plus C2, IC1 minus IC2 for that. So this is solution of it. Now next part, y double dash minus 4y dash plus 5y equal to 0. So this has, you have to write in well manner. This is given differential equation. Then characteristic equation of this equation is r square minus 4r phi equal to 0. Then try to find roots. If you are able to write directly, you can write direct root of this equations, or you can just factorize it. So what are the roots of this? What are the factors? What are the factors? That's correct one, yeah. Can you factorize it?
2 plus I and 2 minus I.
2 plus I, this type of root. So r plus 2 plus I, r minus I take common 2 plus I, like this. So our first root I called it as 2 minus I, and second root I called it as 2 plus I. Then as per the rule, e to the power r1x, that is 2 minus x, solution, one solution. And another solution which is independent of this solution is this. Which one it is? E to the power 2 plus I into x. So these two are solutions. These two are independent solution of this order 2 differential equations. And every solution of this linear differential equation of order 2 homogeneous equation, you get it as like this. Just linear combination of these two independent solutions. Every solution is written as linear combination of these two. And now we can further expand it. You can try to find new constant. You can keep value as it is, but if something asked to prove, then you have to move further here also. So C1 e to the power 2x into e to the power minus 2ix. Next part, C2 e to the power 2x into e to the power. Okay, here should not be 2. 2x minus ix असेल इथे, आणि इथे 2x plus ix. कसं आहे ते? हे जे पॉवर आहेत ना हे 2x plus ix याप्रमाणे, and this is 2x minus ix like this, and exponential law of indices you can apply here because base is e. What you get? C1 e to the power 2x. This is multiplied by what is e to the power minus ix? It is cos of x plus because of minus you get minus here minus I sin x. And C2 e to the power 2x. E to the power 2x is common. C2 e to the power 2x, you get this as cos of x plus I sin x. E to the power 2x कॉमन काढा आणि मध्ये cos आणि sin चे कोएफिशिएंट लिहा. So you get e to the power 2x as a common. What is the coefficient of cos? The coefficient of cos is here, the coefficient is C1 and there the coefficient is C2. So C1 plus C2 plus the coefficient of sin is minus IC1 and there the coefficient of sin is plus IC2. This is multiplied to sin x. So you get this as e to the power 2x. I called C1 plus C2 as D1 cos x and this term I called this as another constant D2 sin x. म्हणजे पहा या ठिकाणी जर रूट्स ए प्लस आय बी असे असतील ए प्लस म्हणजे कॉम्प्लेक्स रूट असेल तर त्याचा कॉन्जुगेट सुद्धा नेहमी रूट राहतो आणि तुम्ही प्रूव्ह करू शकता. तर एखाद्या इक्वेशनचं ए प्लस आय बी हे रूट असेल तर त्याचं ए मायनस आय बी हे सुद्धा काय असतं रूट असतं. त्याचं कॉन्जुगेट त्या इक्वेशनचं रूट असतं तुम्ही ते प्रूव्ह करू शकता. मग अशा ठिकाणी याचं जनरल सोल्युशन काय असेल? e टू द पॉवर एक्स कॉमन काढलेला आहे. वन कॉन्स्टंट त्याला मी D1 नाव दिलं D1 टाइम्स cos bx प्लस अनदर कॉन्स्टंट D2 टाइम्स sin bx याप्रमाणे सोल्युशन तुम्ही कॉम्प्लेक्स रूटसाठी असं नोट करू शकता समजा या ठिकाणी किंवा नाही केलं तरी चालतं. युलर्स फॉर्म्युला वापरून तुम्ही शेवटच्या स्टेपला येऊ. या ठिकाणी D1 D2 दोन कॉन्स्टंट आले आणि इंडिपेंडंट सोल्युशन कोण आहेत? e टू द पॉवर 2x cos x आणि e टू द पॉवर 2x sin x. वरचे पण बेसिस आहे खाली काढलेले पण ते सुद्धा काय बेसिस वेक्टर होते. One more example for this example. What was that example? Y double dash plus now complex coefficients are there 3i minus 1 y dash minus 3iy equal to 0. This given differential equation has the characteristic equation like this. Okay, just compare with x plus bx plus c. And what are the roots? Minus b plus or minus b square minus 4ac divided by 2ac. So here value of a is 1, value of b is 3i minus 1, and value of c is minus 3i. Just you need to calculate it. Calculate करायचं आपल्याला या ठिकाणी. काढा बरं काय येतं आता हा b square minus 4ac काय येतं ते काढा. What is value of b square minus 4ac? Or can we factorize here? If you are able to, then okay. हे फॅक्टरायझेशन करू शकतो आपण याच्याकडे पाहिलं तर 3i minus 1. 3i आणि minus 1 यांचा प्रॉडक्ट काय आहे? 3i आणि minus 1 यांचा प्रॉडक्ट हा आहे. या ठिकाणी या दोघांची बेरीज असेल तर यांचा प्रॉडक्ट किती असेल तर आपण a आणि b त्याचे रूट आहे असं म्हणू शकतो. म्हणजे पाहता या ठिकाणी कशी ऍडजस्टमेंट करतो मी हे किचकट करायची गरज नाही. आपण बघू प्रयत्न करून या ठिकाणी r स्क्वेअर प्लस 3ir मायनस r मायनस 3i. या ठिकाणी मी r कॉमन काढतो. r कॉमन काढल्यानंतर काय येईल r प्लस 3i आणि या ठिकाणी मायनस 1 कॉमन काढतो r प्लस 3i. आता पुन्हा हा ब्रॅकेट कॉमन निघेल म्हणजे काय r मायनस 1 कॉमन निघाला आणि साईनचा प्रॉब्लेम आला या ठिकाणी. 3i ला साईन पॉझिटिव्ह 3i चं साईन 3i मायनस 1 हे तर बरोबरच आहे. ठीक आहे. r plus 3i equal to 0. So what are the roots? वरचे ते आपल्याला डिस्क्रिमिनंट फॉर्म्युला वापरून काही गरज नाही. क्वाड्रेटिक रूट्स आपल्याला रूट डायरेक्ट मिळतात त्या ठिकाणी. एक रूट r इक्वल टू 1 आहे आणि दुसरा रूट r इक्वल टू मायनस 3 आहे. नाउ वी कॅन राईट द सोल्युशन ऑफ इट. आपण इझिली याचं सोल्युशन लिहू शकतो. आता आपला जो बी r चा कोएफिशिएंट जो होता तो काय होता प्रॉडक्ट ऑफ द कॉन्स्टंट टर्म म्हणजे c आलेला त्यामुळे आपण इथे डायरेक्ट करू शकलो. मग आता सोल्युशन काय या ठिकाणी सांगेल कोण मला? एक सोल्युशन येईल e टू द पॉवर फर्स्ट रूट I call it as R1 and I call it as R2. R1x म्हणजे x. आणि दुसरं सोल्युशन काय येईल, a to the power minus 3ix. So these two are solutions, and every solution of this differential equation given by the linear combination of these two, as usual. The general solutions are all solutions given by this formula using these two constants. Now this gives c1 e to the power x plus c2 याला आपण trigonometric form मध्ये लिहूयात cos of 3x minus I sin 3x. That's it. नाही लिहिलं तरी चालेल, या ठिकाणी हे त्याचं सोल्युशन आहे. हे दिलेलं इक्वेशन सॅटिस्फाय करतं. Any difficulty? You can ask. Yes. Find any difficulty here? अशा असंख्य एक्झाम्पल तुम्ही सोडू शकता, फक्त तुम्हाला रूट्स त्या इक्वेशनचे काढता आले पाहिजे. Okay, we have another exercise example from book. Consider the equation. Consider the equation y double dash plus y dash minus 6y equal to 0. Compute the solution phi satisfying phi of 0 equal to 1. Now its order is 2. You must have two conditions given. Phi dash single dash phi dash mean derivative with respect to x. The same conditions, same points are given, means this should be initial condition. And another b part there. Compute the solution psi satisfying, because its order is 2, you must have two basic solutions phi and psi instead of phi 1 phi 2. Psi of 0 equal to 0 and psi dash 0 is 1. And third part, once you find this phi, compute the value of phi of 1. Once you find the psi, compute the value of psi of 1. Now here it is not asked to find all solutions. What is asked? Compute the solution phi satisfying this condition. आता तुम्हाला दोन सोल्युशन मिळतील, त्यातलं एक phi हा कंडिशन सॅटिस्फाय करेल. त्याच्यावरून तुम्हाला ओके, त्याच्यावरून त्या कंडिशनवरून तुम्हाला हे काढायचं, कॉन्स्टंट्स काढायचे दिलेल्या कंडिशनवर, आणि पुढच्या दिलेल्या कंडिशनवर ते कॉन्स्टंट काढायचे. म्हणजे हे दोन सोल्युशन्स काढायचे तुम्हाला phi आणि psi. येईल काढतो तुम्हाला. Given differential equation is y double dash plus y dash minus 6y equal to 0. The characteristic equation of E is r square plus r minus 6 equal to 0. So try to find root of these equations. If you know roots, you can tell me. So we can write this as r square plus 5r minus r minus 6, like this. Minus 6 can be written as 5 minus 6 should be written as product of two terms. So I call it as 6r. 6r minus r is काय लिहितं power factor याचे?
Plus
Plus 3
3
minus 2.
minus 2 plus 3 minus 2.
3 आणि 2 3 दोन्ही 6 बरोबर आहे. Okay, right, I will rewrite it again. R square plus
Plus
3r
3r.
minus 2r minus 6 equal to 0. So this implies r
R plus
plus 3
minus 2r plus 3.
minus 2 common काढणार आपण इथून r plus equal to 0. So factors are r minus 2 and r plus 3 equal to 0. So 2 and minus 3 are the roots of this equation. So this implies r equal to 2, I call it as r1, and r2 equal to minus 3 are two distinct roots. As per the rule, you have, okay, we will write general solution, all solutions. Thus, phi1 is equal to e to the power 2x and phi2 is equal to e to the power minus 3x is our independent solutions, solution of given equations. And every solution of this equation is given by c1 e to the power 2x plus c2 e to the power minus 3x. And we have to find, now this is your phi. Now we have to solve first one. This given that phi of 0 is 1. Phi of 0 is 1 means what? C1 e to the power 0 plus C2 e to the power 0 equal to 1. That is one equation, C1 plus C2 equal to 1. So when you have two variables, two unknowns, find you need to have two conditions. That's why I'm telling that the order must be, when order is 2, you must have two conditions given. So phi dash x means 2 times C1 e to the power 2x, e to the power 2x are directly like minus 3 times C2 e to the power minus 3x. आणि phi dash of 0 आपल्याला काय दिलाय? Phi dash of 0 आपल्याला 1 दिलेलं आहे. या ठिकाणी 2c1 minus 3c2 equal to 1. e to the power 0 आपण 1 दिला, e to the power 0 या ठिकाणी आपण 1 दिला equal to 1. हे दोन इक्वेशन सायमल्टेनियसली c1 c2 साठी सोडवायचे आणि c1 c2 च्या किमती मिळाल्या की त्या मध्ये ठेवायचे, तो झाला phi. तसंच त्याला साय म्हणायचं आणि दुसऱ्या कंडिशन पाहिजे दुसऱ्या पार्ट. I'm writing that two conditions, c1 plus c2 equal to 1, 2c1 minus 3c2 equal to 1. Solve this simultaneously. Okay, what I will do, I will just multiply it by 2 to both and just subtract it. What you get? 5 c2 equal to 1. C2 is 1 upon 5. What is the value of C1 then? Just calculate anyone. C2 is 1 upon 5, then what is value of C1? C1 plus C2 is 1. So it should be 4 by 5. Just we check it. Both satisfy both equations. If C1 is C2 is this, we know that C1 plus C2 is 1. That means 1 is 1 upon 5, other has to be 1 minus 1 by 5, that is 4 by 5. So phi of x. So this is the phi of x, that 4 upon 5 into e to the power first root, e to the power 2x, I think, e to the power 2x plus 1 upon 5 e to the power minus 3x, satisfying, you can easily check, satisfying phi of 0 equal to 1 and phi dash 0 equal to, it is also 1. चेक करू शकता तुम्ही. तर आपण या ठिकाणी phi dash 0 ठेवला तर 1च येतो, C1 C2. आता त्याला साय म्हणायचं आपल्याला. दुसऱ्या ठिकाणी दुसऱ्या प्रॉब्लेम मध्ये काय साय नोटेशन वापरलं? General solution is given by, now the function is denoted by psi of x. So psi of x is written as c1 e to the power 2x plus c2 e to the power minus 3x. But conditions are different. What are the conditions? Psi of 0 is 0 and psi dash of 0 is 1. So these two conditions gives two different constants and that will be your psi of x. Psi of 0 काय देतो? 0 म्हणजे काय आलं इक्वेशन? c1 plus c2 equal to 0. आणि psi dash हा काय येईल? value of psi dash it is 2c1 e to the power 2x plus or plus minus 3 c2 e to the power minus 3x. So psi dash 0 हा 1 दिलेला आहे म्हणजे 2c1 minus 3c2 equal to 1. इथे आपल्याला कळलंय c1 आणि c2 काय आहेत एकच आहेत म्हणजे एकमेकाच्या अपोजिट साइन मध्ये आहेत. c1 equal to minus c2 ठेवलं तर आपल्याला काय येईल minus 2c1 minus 3c2 equal to 1. तर तुम्हाला c1 च्या जागेवर आपण minus c2 ठेवलाय. Instead of this c1 we put minus c2 आणि c2 काय मिळाला आपल्याला minus 1/5. If c2 is minus 1/5 then what is c1? It should be 1/5. So just put this c1 and c2 over here. या ठिकाणी c1 आणि c2 ची किमती ठेवायच्या. काय 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 इक्वेशन फंक्शन काय psi of x equal to 1/5 e to the power 2x minus 1/5 e to the power minus 3x. याच्या ठिकाणी 0 ठेवला तर 0 मिळतंय बरोबर आहे कारण c1 plus c2 0 आलेला आहे आणि psi dash च्या ठिकाणी 0 ठेवला तर ते 1 देते तर तेही बरोबर आहे आपण त्या कंडिशन प्रमाणेच काढले. सो दिस इज द फंक्शन psi आणि phi and psi या ठिकाणी डिफरंट आहेत पण डोंट forget that both the phi and psi are the linear combination of that e to the power 2x and e to the power minus 3x. That means they are basis functions for the solution space of given second order linear homogeneous differential equation. Once you find this psi of x, okay, I'll write psi of x is 1/5 e to the power 2x minus 1/5 e to the power minus 3x. In the C part, it was asked that what is phi of 1 and what is psi of 1. Okay, psi of 1 I can write a square upon 5 minus e to the power minus 3/5. So e square minus e to the power minus 3 divided by 5. This is psi of 1. And what is phi of 1? Phi of x काढला आपण इथे. What is phi of 1? Phi of 1 is 4/5 e square plus 1/5 e raised to minus 3. 4/5 e square plus होता का minus plus 1/5 e to the power minus 3. So this is phi of 1. This is psi of हे फक्त कॉम्पिटिशन करायचं दुसरं काय नाही. I will ask another problem to solve you. Third example. Find, you have 1 minute, okay, I'll write this and you just take screenshot of it. Once it is solutions, find all solutions phi of what? The given second order linear homogeneous differential equation. Okay, this is that equation. Satisfying. This is homework to you. Satisfying phi of 0 equal to 1, phi of pi by 2 equal to 2. B part. दोन कंडिशन दिलेत आपल्याला phi of 0 equal to 0, phi of pi is 0. म्हणजे एकदा phi काढून घ्या आणि मग त्या कंडिशन प्रमाणे phi बदलत राहील म्हणजे कॉन्स्टंट काढायचे तुम्हाला दुसरं काय नाही. C part phi of 0 equal to 0, phi dash pi upon 2 is आता याचे रूट्स तुम्हाला प्लस और मायनस आहे दिसतात या ठिकाणी त्यामुळे ट्रिग्नोमेट्रिक पार्ट्स इन्व्हॉल्व या ठिकाणी आणि डी हे दोन इक्वेशनवर दोन कंडिशन काढायचे आणि ते कॉन्स्टंट सर्व शोधायचे. कॉन्स्टंट शोधलेले तुम्हाला आधी phi1 आणि phi2 सोल्युशन मिळेल म्हणजे c1 phi1 प्लस c2 phi2 असं सोल्युशन मिळेल. या phi मध्ये किमती ठेवायच्या. phi1 काय याचं रूट आपल्याला दिसतंय क्लिअर कट इथं रूट काय आहे प्लस और मायनस आहे म्हणजे e टू द पॉवर ix आणि e टू द पॉवर मायनस ix हे दोन सोल्युशन्स आहेत त्याचं कॉम्बिनेशन